the ray of light reflected inside the isosceles triangle 8 times, part 2. Here we see the isosceles triangle ABC, and here AB is equal to AC, and point D is the start point of the light ray, point D here, and we denote here distance between A and D by this symbol D small, and then DE, it means first segment of the trajectory of the light ray is perpendicular to AB, from perpendicular to side AB. The ray of light starts perpendicular to side AB, and also we know that incident angle is equal to reflected angle, and point D located between points D3 and D4 and distance from A to D3 is cosine of angle A multiplied by 3, and the distance A D4 is equal to cosine of angle A multiplied by 4, and then angles E, F, G, H, I, J, J, F, K, and E and L. Here we computed them, and we get angle L is equal to 90 degrees. It means the angle of start of light ray and angle of finish of ray of light are perpendicular. Angle D, we suppose that it is 90 degrees, and angle L, we computed this angle according to this angle of it is law of optics. Incident angle is equal to reflected angle, and we can compute all these angles, and so point L of the trajectory last point, because from point L the ray of light will return on same points, on same trajectory, but in opposite direction. And now we need to prove that length of trajectory of ray of light, the length of this trajectory is equal to dE plus EF plus FG plus GH plus HI and plus IJ and plus JK and plus KL. All these 8 segments give us this expression, sine of A multiplied by 3 plus sine of A multiplied by 4 for any point D between point D3 and D4, between these points, and not depends on D. In each point between D3 and D4 start point, we get trajectory with length of this expression. We saw in third secret such formula, and in second secret before this it is for 6 segments, and this formula for 4 segments, and we can here to suppose the common law that here we see this law, and in previous part was proved that sum of members of L8 with D, so it means depends on distance D. We proved in previous part that this sum of members that depends on D is equal to 0. And also we computed segments DE equal to D tangent A, and also segment EF we computed in previous part, and segment FG also we computed in previous part. Then sum of DE plus EF plus FG is cancelled because by corresponding D members of KL, JK, and IJ, and also D members of GH and HI cancel each other. Therefore, L8 length of trajectory is equal to sum of these 5 segments. It means expression members where them commands denote segments GH, HI, IJ, JK, and KL without D members because they are cancelled corresponding members. And so we also prove these expressions. We computed it in previous part, and so 8, it means total length of the trajectory is equal to these expressions, and now we do here some transformations, and we can see that we get such expression here, and here we continue work with these expressions, and we can see that we transform these expressions, and we use here a usual formula of school for transformations, sum of cosines to product of cosines and product of sine and cosine. Also, we can transform to sum of sines, and this third formula, product of cosines, we can represent by sum of cosine, and here we can see these transformations, and we see that this is proved. This our goal is achieved, and we here get expression that we expected here from its value. And after this, we want to formulate common law that is on base of this optical phenomenon.